Thank you. Thank you, everyone, for attending this talk. So my talk is mainly an application for the machine learning and data mining techniques in the medical analysis. So you can see from the topic, we look at the cancer detection. And there's a special type of cancers we're looking at is the thyroid cancer. So give you a bit background of where the thyroid is. So you'll see a butterfly shape at the bottom of your neck. So this is a very important part of your body because it controls everything. So you will have it, if it's healthy, it will control your heartbeat. It will control your temperature. So you are full of energy. If you have any problem there, many people will have, it's like pretty easy to get tired, and you don't have any energy to work on something new. You lose interest. So that's a very hard presentation or expression on your body. You may not notice it. And this is a quite serious problem. Why? Because you will see over the whole world, you can guess how many cases we have. 300 million. 300 million people suffering for the thyroid cancers in 2018. And they're still growing. 123,000 cases every year. And from the map, you can see this is a heat map. We are all familiar with that. Did you see Australia? Yeah, sorry, we are in the top group. Okay, so some factors we have to face is like, this is a very fast growth disease. Even it is not a immediately killer, but many people suffer from that because it has really bad impact on your daily life. It's not like the other cancers which will put you down straight away. You still can work, you still want to work and live in a normal life, but you feel like helpless. So slowly, it may have some impact on you later. Okay? And we also notice that female has a bit higher, or say much higher chance, 3 times more chances to get this disease than males. But for male, you will see the age group, 30 to 39. This is maybe the best 10 years, or say most important 10 years in your life. You're so full of energy, but you cannot. And the cause of this disease currently is unknown. Our work, we try to look at people's lifestyle, their diet, their habit, what they do in the daily life, try to find the cause, but very, very hard. So we put our eyes on the detection, or say diagnosis. Then we go back to the doctors in the clinic and ask, how can they detect the cancer, or say the thyroid diseases? So they will do the blood test first. So like the other test you will do, your GP will ask you to get some blood and test a couple of the items, then read those numbers and try to identify if there are any problem. If no, or if they find a slightly difference from the normal range, they will send you to do some scanning. So in Australia, we do ultrasound scans. Right. And in the other countries, they may also do the CT scans at the same time. Then they try to find out what's wrong with the thyroid. So they look at this area and try to see is there any abnormal shapes they can detect, right? It's like the one in the image, you can see a large noodles. At this stage, they just know there's something in your thyroid. But is it good? Is it a normal one? Or is it a cancer? No one knows. I have to warn you that I will show you some picture. If you don't like to see any needles, please close your eyes. And then I will remind you when you can open it. Okay? So this is the needle they use. Pretty long one, right? And it will be inserted into the thyroid blade, try to get some tissues out, and do the test to see whether this is a healthy one. You ignore that, we keep on observing it, you come back and check every 6 months to 1 year. It's okay. If there's anything wrong, your doctor will give you a call, right? But for all these processes, the patient needs to pay for this test. Quite expensive. And unfortunately, more than 30% of the test cannot give you any conclusion. No one knows what happened. So the patient will be asked back to the clinic and then do the test again. You can guess how many tests they will do. 3, 5. That's a normal number. So huge pressure to the patient. They have mental stress because think about it, there's a needle inserted into your body. And you're waiting for the result for 1 week, 2 weeks. Then you have nothing. And ask you to come back and pay the money again, right? So many patients, they did not receive any conclusion or continue for any treatments because of the financial problem, right? If we leave it there, it will slowly develop, but one day it may kill people. So our work as AI or machine learning researchers, we try to reduce this kind of pain. You will think about it's like if we can use a computer model to simulate, to automatic find out the problem from the image. It's like just look at their skin. Skin won't make you feel painful. Maybe it will have some like X-ray impact on your body, but it's not as serious as that needle, right? So people will feel much better if we can do that, and we do it quickly. You don't need to wait for 2 weeks. You can get the result the next day, or actually in the lab, we just need 3 hours. Okay. So some challenges. Here, we try to improve the detection accuracy to shorten the process of diagnosis. So the patient and the doctor, they can know the result a bit soon, right? To reduce their mental pressure. And we also try to avoid that repeated needle test. So they will have some financial release as well. Okay. We have done a bit study from the literature and find the existing machine learning method used in this area, there are still like some classic ones like LDA, like SVN, even they use KNN and random forest. They will just look at the blood test result, numeric data. They may look at the image, but ultrasound in most of the cases. And the detection accuracy is not that high, it's around 80%. Okay? So we think about its image. why not we use deep learning method? So we introduced that to this area. And we also look at both images, because we have the collaborations with the hospital in China, and we can get some CT scan images. So we put them together to see if we look at the ultrasound, what is the accuracy we can get? If we look at the CTs, what we can get? If we combine them together, is there any space that we can improve it? So this may be the suggestion we can give to the doctor, say, what exactly the test, the scans you should suggest your patient to take. Then we also look at the most of the work in this area looking for just the boundary detection. So they can only tell you this is a normal one or this is an abnormal one. But there will be a number of the thyroid diseases in the clinic treatment. It's like you may have a noodle. It can be a small one. It can be a big one. It can slowly develop, or it can slowly disappear. So what exactly the disease is? Few works look at this point. And we also try to find out, is there possible we can give a correct detection? I will show you the picture later, why I say the correct one. Okay? So thyroid is a bit special for the medical. Give you the framework first. So we gather the images, right? And we have some pre-processing. We ask the domain experts to help us do the labeling. And for the labeling, we have the boundary ones, like you will have the normal one and abnormal one. We also look at the special diseases the surgeons, they are quite interested in, including the cancer. Okay? Then we have the ultrasound pictures. So for the ultrasound, if you ever tried ultrasound before, you will see they will just cut a small piece of the area. They are interested in the report, right? And hard to tell where actually it is located in your body. We also have the CTs. So the CT, there will be the whole areas, right? And then remember, it's a butterfly shape. You have the left and the right. You may have a nodule on left or on right or both sides. So we further divided them into the left side and the right-hand side. Okay? So for each of that, we give a individual channels to create a CNN models. Then we combine them. Our work will be able to tell the single disease or the combination. The combination comes from, may have several nodules on your neck. They may be different diseases. They may be on different sides. Then through the CTs, we'll be able to tell if there's a mixed one. Okay? So a general idea. And then for the CNN models we created, we use dual channels. The reason to do that is we applied different size of the filters. The small size and the big size. The smaller ones will go for more detailed. And the big size will look at big areas for the a more rough features to extract it. We apply this on the ultrasound imager and also the CTs. So by combining that, it will give us a good result. So still remember, the existing work use KNN, use SVM, use LDA. They reach about 80%. Some of them may reach 90%, but we can get about 98%. We also look at the individual diseases. Okay? The confusion matrix gives you some idea. You can see we can detect most of the individual disease by itself. Okay? So this will provide some assistance to the doctors in the clinic to help them to make some decision. We're not replacing or say they can fully depend on our model, but this can definitely speed up their work. For a radiologist, they need years of training to understand the image for the ultrasound. If it's a very clear, just one single noodle, you can find it's not the butterfly shape. That must be something wrong. But what is it? Where is it? How big it is? So each pictures may take them 10, 15 minutes to look at that and think about how many cases in the world and how many people we need. Right? So by using this, we do the trainings on two data sets. One is the benchmark one, another is the image we got from the hospital on 200 patient cases. There's nearly 2,000 pictures from each side, and then we can get these answers in 3 hours. Okay, so see the big difference. Some contributions from this work. It will be possible for us to provide suggestions for the patient clinic design. Because we will be able to give the suggestion like ultrasound is the same or very similar result as the CTs. So for Australia, CT scan is quite expensive, and you need to wait for a long time. You cannot get the appointment right away, right? You may need to wait for a couple of days, lucky, sometimes even weeks. If we just use the ultrasound, we still can get a similar accurate, so that will be good enough for Australia. For the other countries, they may have more facilities, that will be fine. But for the other countries, maybe they can only afford one, then they can pick which one is available for them. So they both give a similar result. Then we can also increase the diagnosis result. It's like 98%. It's not say perfect, but it's okay. Still can give some advice. If they're still struggling for that 2%, they can do more tests. Maybe the needles later to confirm that. We can also use multi-channel to deal with different sources of the images to work on this. So CNN is not just one single model. It was trained based on different model, and then it can provide different results. And even the feature maps we extracted in the hidden layer can be used further. The society benefit. Definitely this helped the doctor to make decision. This also helped the patient to release from their pressures. So for this work, it is a PhD project. We've been working for 3 years right now. We also look at the potential treatment on this. Definitely, we're looking for some new students to join the project if you are interested. And we have the cooperations with the Faculty of Medicine, Nursing, and also the Alfred Hospital, and the hospital from China, which can provide us more data we can train. Okay, so that's it. That's a small work we've done for the medical. Thank you. Oh, and special thanks from my dog and my cats. And they say, be nice to my mom. Don't ask a hard question.
Thanks so much, Jackie. Fantastic that you bring down the first time to a result from days and days to just a couple of hours using big data and machine learning. Questions from the audience? We do have time for one or two. There's one in the center. Can we have a roving mic up there? Jayo.
Hey there. Thanks for the talk. I had a question about the diseases. So, are the diseases themselves mutually exclusive? And if not, can these models potentially capture comorbid diseases?
Sorry, can you...
Yep. So the diseases that your model is training for, are those diseases mutually exclusive? As in, like, can they occur simultaneously, or are they completely different classifications?
They are very similar, to be honest, if you look at the images, but they do have its special features. Like, you will see a round shape. It's like to our normal people, you will see it's just a noodle. It's like big or small size. But it's actually have different shapes and different colors, because it's from the ultrasound, it does not show much difference you can see. It's just like the more darker or more light colors. Mm-hmm. But for the CTs, you can clearly see what's inside. And that different colors tells you what is the tissue inside. It may be a liquid, or it may be fiber. For those, they will be safe. If it has kind of mixed things, then it will give you the warning there may be something wrong. And the round shape, normally it's okay. But if it's not that perfect round, mm-hmm. you will see most of the cancers like that. So this will cause the problem. And also the location of the noodle.
Okay, but so then, like, where you had up there, let's say, like cancer and I think cytosis and things like that, can those two things occur at the same time?
Yes, if it's you may have a noodles which is normal, or it is a just like thyroid disorder. Mm-hmm. You may have another one is a cancer. So okay. Ours can tell you what it belongs to, because you have the combination.
Okay.
Yeah.
Sweet.
There was one more question here at the front. Was it Peter here or anyone else? And we have maybe a super quick one then afterwards.
So
maybe I'll hand it over.
Yeah.
Stand right there. And now I turn the microphone on as well. Thank you.
I'm just interested in how much training data do you have for this kind of problem?
So for the trainings, we use 200 patients, and then they have about 2,000 pictures, because it's very hard to get those pictures, to be honest. So this is like a conversations over about 1.5 years, and we actually have the student is luckily blocked in China because of the COVID, and so she really go to the hospital and collect all these images and discuss with the doctors together to get it labeled. But we do use the sampling techniques to enlarge the data set. So the original one is I remember it's about 1,900 something. And then we enlarge it, because we rotate it for different directions, and then we just fold it so to make it looks like different pictures.
So how deep is your deep network?
So we use the X exception. So I really cannot remember that, because we've tried a lot. Yes, and this is one of the work, and we actually have 3 papers on that, step by step, to look at the different types of disease individually. Yeah. So, but the paper is published, so you can check the detail. But definitely, because it is a CT and ultrasound image, it's different to the true color images, so the layers are much less. And I think we also have high speed because we have less parameters trained. Yeah.
All right, one quick one here at the front. Is it Islam?
Yeah, thank you for a really interesting talk. If I understand what you were saying correctly, you've got the ultrasound data and the CT data and you use it together, but one of the advantages is that if an institute or a group only has access to one type of scan, they can just use the one and it will still work. Could you quantify how much of a step down in performance you get, or I guess how good the model is if you only have one of the two types of data?
Yes, we did do all this experiment because I didn't show you that because there will be hundreds of tables you will see. Yes. So I can say it's very, very close. It's like 98% and 97% or even 96%. So it will be just 1 or 2% differences. Yeah. True. So that's why we suggest that if they only have one type of the image, they still can get a promising result. Yeah.
Terrific. Thank you.
All right. Mark, Jackie, are you going to be around for a couple of hours? Yes? At least 1 hour? Okay, fantastic. Good. So, Mark, is there anyone else who has questions, please do ask Jackie then once we have the poster session. Cool. All right, let's thank Jackie once more for helping people.
Thank you.